Assalamu alaikum students, today is our online lecture number 4 and in this lecture we will study the basic concepts about the MATLAB because in every method you have to implement that method in that algorithm. You have to construct the algorithm and you have to implement in some programming language, and we will study MATLAB, so you must have some background knowledge about MATLAB. And then let's start this video. So first of all you have to know about what is an algorithm. So to make a computer do anything, we have to write a computer program. To write a computer program, you have to tell the computer step by step exactly what you want it to do. The computer then executes the program following each step mechanically to accomplish the goal. So an algorithm is a procedure that describes a finite sequence of steps to be performed in a specified order. The object of the algorithm is to implement a procedure to solve a problem or approximate the solution to the problem. So that is all about algorithms and how you apply the algorithms and what is the main objective of applying the algorithms to solve the mathematical problem. So we start from the basic MATLAB, very basic commands. So MATLAB stands for the matrix, and it is a two-dimensional array of numbers, and lab is for the laboratory. So whenever you open the MATLAB, it shows some kind of a command window. So it is the main window. It enters variables and executes the program, and also you work and you write the script files in the editor window. So open the editor window by this. In the menu bar you have to select the file, a new script file. So that opens the editor window. It creates and debugs script and function files, and the menu bar is shown by this picture. You can see that this is the command window, this is the history window, and the current directory. Okay, let's start in writing in the editor window. So first is that if you want to find any answer of this very basic arithmetic operation, like if I enter A is equal to 3, B is equal to 5, and C is equal to A plus B. So output will, if you enter it, or if you have a modified variant, then you click the this green play signal, and that is sign, that is for the execution, or it runs the program. So if you run the program, then your output will be output equals to 8. It is shown in the command. So the semicolon represents that the statement, it is the end of the statement, acts to suppress the output. It doesn't show in the output. So semicolon hides the statement basically. If you don't apply the semicolon, then it is not followed by if the statement is not followed by the semicolon, the content variable is dumped as the the meaning of A equals to B. So A is equals to sign means assignment operator. So here it is not equal to sign, it's not an equal sign, but it is the assignment operator. And if you want to apply the equal sign, you must write A equals B. One is for assignment operator and the other one is for equal sign. A equals to 3 and B equals to 8. Okay, the value of A is 3 here, and the value of A is assigned to B. So output should be P of B, because both have the semicolons, and in the third statement B is simple written. So the output is, because A is assigned to B, so B is equal to 3. Okay, so basic mathematical operations is if A is equal to 3 semicolon and B is equal to 9. So both these statements are suppressed and it will not show in output. And C is equal to 2 into A plus B to the power 2 minus A into B plus B divided by A minus 10. Now remember that in these type of calculations, it will follow that BDMAS rule. First bracket is solved, and then division, and then multiplication, and then addition and subtraction. So what will be the C? The output will be, if you execute this program, the output will be 53. It is the calculated variant of this one. So if you want to update any variable, like example 4 is A is 3 and A is equal to A plus 1. So A is basically 3. So 3 plus 1 is 4. Now A is updated. Show any kind of a statement to be written in the output. Then you can use two commands. One is fprintf and then bracket and in single inverted commas, and whatever you write will show in the output. like fprintf bracket hello. And also if you write error brackets and single inverted commas, and whatever you write in the bracket it shows. So error and fprintf are just for formatted output. So that if a is equal to 3 and b is equal to a into a and c is equal to a into a and d is equal to square root of a. So all these have semicolons, and fprintf has this specific like for u squares equal for u backslash r means it completes or it ends the statements, comma a comma b. For u means output will be 3. For u means a 3 equals b is 3 square, so 9. Okay. Again for u cube equals a comma c. That means for u is a, 3 cube equals c is a cube, basically a into a, so it is 27. And the square root of 3 is square root of 2u. 2u is a, that is 3 is 6.4f. 6.4f is up to 4 decimal places. So it shows the square root of a, square root of 3 it shows. Okay. The command fprintf is for formatted output using the format specified in the first string in the parenthesis, and the symbol percentage for u is the 4-digit integer. Okay, it's a 4-digit integer, and 6.4f is the real number that preserves 6.4 that preserves 4 digits to the right of the floating point. After the floating point, it must include the 4 digits. And MATLAB usually do the iterations or calculations up to 4 decimal. MATLAB use the up to 4 decimal places. It does the calculation up till you write the format long. Okay, which will show you 16-digit calculations after the floating point, decimal point. So the square root is the fourth statement, and yes, square root, sqrt is for the square root. This is the command. So anything you write in it is in the form of a matrices or in the form of an arrays. If it is a one-dimensional matrix, then it is of the form of array. So if you want to write the arrays like a is equal to 3, 6, 7, so that is first row of the of any matrix, only one row. Okay, so 3, 6 row are written as by spaces or by commas. 3, 6, 7 is equal to 3 space 6 space 7 semicolon. First array and second array is 1 9 space 9 space 4. So these two arrays, and you have to add those arrays. So that means element wise it is addition. C equals to a plus b. So 3 plus 1 is 4. Output will be 4. 6 plus 9 is 15, and 7 plus 4 is 11. So this is element by element addition. Okay. If you want to extract an individual entry in the of an array, then you can extract that C is equal to A of 2. That means second element of the array A plus B of 4. Fourth element of an array B. So A of 2 is basically 6 and B of 4 is 5. Fourth place, element at the fourth place, and that is 5. So 6 plus 5 is C, output C equals to 11. So you can also extract any individual element in a one-dimensional array. Okay, next is comment. Yes, comment is for percentage symbol. If it is highlighted in the form of a green color, and that means it doesn't affect the statement, or the statement execution of the statement doesn't affect on these comments. So this program demonstrates how to comment out the segment of a code. Just to explain that this statement means this, so that explanation is given in the comment. Or if you want to exclude something, then you can write in the form of a comment, so it turns into green and this statement is not executed. So it is given in this example. 9. Okay, continuation to the next line. If you want, if the statement is so lengthy that you want to continue it, then you use the 3 dots or 3 periods. That means that allows the continuation to the next line of the commands. One more thing, if you want to write something from the next line, then you write fprintf, write the statement and write \n, that means new line, and then the next of the statement, rest of the statement will start from the next line. So \n is for the new line. Okay, clear? It has so many basics that it cannot be covered in one lecture. So just okay, clear all is used for clearing, or CLC. If you want to clear the screen, then you use the CLC command. And also help command shows lists of commands. Okay, and help space disp, it shows info about one specific command. If you want to know about one specific command. And doc, doc, if you write doc space disp, then it shows documents basic structure. Okay, intrinsic math function and constants. Like constants are pi, and pi cannot be written in the form of symbol. It is just written as pi. That means pi. It will take the value of pi. And if you want to write the exponent, then you can write it as exp of brackets, exp brackets and some value. Exp, that means everything written after exp is in the form of a power. Like exp of a 2 means exponential, e to the power 2. So example 1 is x equals to pi, y equals to sine pi by 2, and z equals to exponent of minus sine pi by 2, in brackets pi by 2. So brackets are very, very important, and it changes each and every calculation if you don't apply the proper brackets. So output is y equals to sine pi by 2 is 1, and z is this value, exponent of sine pi by 2. Okay, so it is minus sine pi by 2. If it is only sine pi by 2, then e to the power 1, that is 2.718, and it means e to the power minus 1, that means it is 0.3675. So, but some constants are the standard constants like pi. You cannot use pi as some name, as some string value, or as some MATLAB variable. It will always assume its value as 3.14159. Okay, okay, if you want to plot, tell the domain. So domain starts from x equals to 0, colon, 0.1, colon, 20. So you want to plot the graph between 0 and 20 with the difference of 0.1. And if your difference is very small, then your graph is more smoother, and if the difference is greater, then your graph is not that much. Y equals to sine of x, that means a sinusoidal curve it makes. And plot is the command basically. Plot of x comma y, then the output will be x will be domain will be 0 to 20 in the x-axis, and 0 to 1 because it fluctuates between -1 to 1. So yes, it is not 0 to 1, it's -1 to 1, and this shows the sinusoidal curve of sine of x. It is a 2D, two-dimensional graph. And you can also use multiple graphs. If you want to plot the multiple graphs, then you use this technique and you use the command hold on. It is therefore using the multiple commands. Okay, basic looping. Okay, for loop, next number of iterations. If you want to do 100 iterations, then it will be done in one step, and that is for loop. So using for command, b is equal to 3, and for k equals to 1 to 5b. So that means 5 times it iterates and the value is displayed b. So for if you use the for command, then for loop, then you have to end that for loop. So you have, for that you have to write that end within to complete the loop basically. So it displays 5 times 3, the value of b. So it is repeated 5 times with the k index going from 1 to 5. Okay, don't use semicolon in front of for because it doesn't execute then. Okay. Next example 15 is for loop, dummy index b equals to 3, and for k equals to 1 to 5 means 5 iterations, 5 times it will be displayed b to the power k. So k is 1 2 3 4 5, so every time 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4 and 3 to the power 5. So that means 3 to the power 1 is 3, 3 to the power is 2 is 9, and 3 to the power 3 is 27, 3 to the power 4 is 81, and 3 to the power 5 is 243. So this is dummy index. Okay, so example 17 is just like that. You have to study, and this is basically a difference between the difference in the loop, like 1 colon 2 colon 3. That means your iteration will be with the difference of 1 3 5 7 9. So you can calculate that. Okay, treatment of an array with the loop. You can also treat with that with the loop, and it will display example 18 and example 19. You can study it, analyze it, and get the output. Okay, you can also use nested loops. Yes, double loop, triple loops, depending upon the situation. You can also use in every numerical method. In every iterative method we can use this nested loop. And then basic branching. Okay, branching is for condition. So condition is if and then condition. If this happens, then that happens. So this statement is written like this. If like in 23 example, if num1 is initialized as a 7 number, and if num1 is greater than 5, then f print as this. Else, if it is not true, then you can go to the else. You can also use else if branching basically. If this happens, if not, else. If this happens, then printf this. Else if. So you can also use many branches in the if else condition. So these all are very interesting examples, and you have to try it. You have to study, you have to analyze it, and you have to understand, comprehend this these examples of if and else. Okay, so next one is array and matrix. So you have a very basic commands about the matrices. For example, come to the example number 28. One-dimensional array, addition of two arrays, like A is 2 12 25 and B is 3 7 4. Remember that it is a one row. B is also a one row. So see, A plus B is element wise addition. 3 plus 2 is 5, 7 plus 12 is 19, and 4 plus 25 is 29. So that will be the output. And also addition of two matrices. So matrices can be written as one row is written by the spaces, and if you want to jump to the next row, then you have to write a column. Okay, so that will jump to the next row, and if you want to end that row, just replace the semicolon, so that will jump to the next row. So that will construct the matrix of that. So example number 29 is A is 3 4 comma 1 6. That means first row is 3 4, elements are 3 4, and second has the elements second row has the elements 1 6, and B is 5 2 first row is, and the second row has 11 7. So see, A plus B is element wise addition. So 3 plus 5 is 8, 4 plus 2 is 6, and 1 plus 11 is 12, and 6 plus 7 is 13. So that is all about this. Okay, multiplication of a matrix. So if you want to multiply a scalar, then it will be multiplied point wise or element wise. And if you want to multiply two matrices, then you have to write like in the example number 31. If you want to apply this, A is a one array and one-dimensional array, and B is also another one-dimensional array, and C equals to A full stop multiplied by B. So dot represents element wise multiplication, and also in the matrices in 2 cross 2 or 3 cross 3, dot means element wise multiplication. Otherwise it is that kind of a matrix multiplication, you know, row 1 with column 1, row 2 with column 1, and all that. So this is a very basic multiplication. If you want to multiply something with a point wise element wise, then you replace this dot. And if you don't want to multiply, you'd want to multiply the journal matrices, then just write steric between the matrices. Okay. And if you want to extract specific element, then if you want to multiply the specific element and the specific element of the other matrix, so you can also extract that element, like a of 1 into b of 1, a of 2 into b of 2, and a of 3 into b of 3. So okay, this is all about matrices and also multiplication of matrices. And if you want, if you have one array like a equals to, example number 34, a equals to 2, 3, 5 and b equals to sine of a, then it means sine of each and every entry. Sine of 2, sine of 3, sine of 5, that will be 0.9092 space 0.1411, and the third one is sine of 5 minus 0.9589. Okay, so this is simple vectorial variables. And also, if you want to extract the diagonal or any element of the matrix, then you can also write the command as di. For example, you have the matrix A, and then you can write it as diag of A. So it will show represent the diagonal of the matrices. And also you can also write it as a of bracket 1 comma 1 plus a of 2 bracket 2 comma 2 bracket close plus a of 3 comma 3 bracket close. So that will represent the elements of a11, a22 and a33. And also, okay, if you want to find out the determinant of the matrix, then use the, if A is the matrix and 3 cross 3 matrix, for example, then use the command det of round brackets of A. That will give you the determinant in just one step. And if you want to get the inverse of that matrix, then you can write it as inv of A. That will show you as the inverse of the matrix. And if you want to show the transpose of the matrix, then you can write it as A equals to, capital A equals to A slash equals to transpose of A, TRANS POSE of A. That will show the transpose of that matrix. And what else? If you want to write the epsilon or absolute function, then you can write it as basically EPS. EPS is for tolerance representation. So it is just for accuracy of the floating point precision. And also ANS means answer. That means most recent answer. And what else? Round brackets means parentheses encloses function arguments and array indices. I will tell you the declaration of the function later on. Okay, dividend is just if it is oblique, then it means right dividend. Dividend divided by divisor. And if it is the backslash, then it is also a dividend, that is called as left dividend, and that means divisor backslash dividend. So first divisor is written and then dividend is written. So it is left dividend basically. And if you want to take the raised to the power, then it is simple, just like a head. It is scalar and matrix exponential operator. And if you want to write element wise exponentiation, then you write it as steric and hat. It will give you the element wise power elements. And then it encloses the array elements and matrices and also function output. If you declare the function, then function output is given in the square brackets and input is given is in the round bracket. I told you if you want to write one column vector, then it is like that. A equals to 1 semicolon 2 semicolon 3 semicolon 4 semicolon 5. That means one column, just one column and 5 number of rows. And if you want to write one row, then either comma or space, 1 space 2 space 3 space 4 space 5. Okay, and matrix and plotting. Okay, if you want to plot the multiple graphs I told you before, then you have to write hold on. And if you want to label, yes, additional features of the graph. If you want to label the graph as x, then if you want to label the x-axis graph, then x-axis labels as x label. X label command is used to label x-axis, and y label command is used for the y axis. And the title TITLE, title command allows you to put a title on the graph. So again, yes, grid on is for it put the grid lines on the graph. If you use the grid on, then it makes the scales of the graph. X is equal command generates the same scale factors and the spaces on both axes. Yes. And x is square commands generates a square plot. So this is x is equal, x is square. X is equal means same scale factors, and x is square means square plot. Okay, if you want to color the graphs, then 8 basic colors you have to use is, you can also write different textures of the graph, like in a dotted form, in a circles form, in some spaces like in the form of the dashes. You can change the texture of the graph, and also you can change the colors. So the standard 8 basic colors are, if you want to make the graph as white, then write the code is W in the single inverted comma. And also if you want a black graph, then K is written, and for blue write it as B, for red R, cyan C, green G, magenta M, yellow Y. So you can use any color, and there are other colors as well. Interesting row and column writing. Okay, factorial, exponentials and factorials. You like exp of 1 will display as 2.7182, and a factorial of 8. For example, p equals to factorial of 8. So it will display the 8 factorial, that is 39900. This is very basic thing. Submatrix. If you want to take the sub part of the matrix, so create a submatrix. Like if submatrix is A of 2 colon 3 comma 2 colon 4. If you enter it, then it will displays all the rows from 2 to 3. Second to third row, it will display the elements of that, and from 2 to 4 means in the column, second column to fourth column. So it will display the elements from the second to fourth column and rows from second to functions. So if you want to start a method, then your declaration should be function function square bracket, whatever you want to write, that is in that square bracket will be the output of that method, equals to some name. Like if you want to start with the bisection method, if you want to start with your own name, for example, if I write it as Sharmeen, that it means SHARMEEN. So function square brackets in that output equals to Sharmeen, and then you will encode the parenthesis, right? Parenthesis means round brackets. So round brackets, in that you will write all the inputs. And one more thing, that now your function is declared, so every file, script file, will be saved in the .m extension, because it is a MATLAB file. And if you don't save that MATLAB file with the same name Sharmeen, or with the same name you have written, then your file will not be opened. So make sure that it is a case sensitive. So whatever the name you declare that script file, you have to save the same name in of that script file. So, any questions, I will tell you side by side while using the program implementation.